Landyne software suite is a collection of practical tools for TEM study in material research and characterization. The current version 6, including 16 applications, all developed use the newest version of OpenJDK. We have created a series of videos to walk you through each software application, including a launcher, which can help you easily access them all. In this video, we'll introduce EMCIP, short for electron microscopy crystallographic image processing. Another application, EMIPA, is for general image processing test, and we will cover that in a separate video. Double-click the Landyne icon. You will see 16 applications in the launcher. Find the EMCIP and click on the icon to start. The application can run either with a license file or in demo mode. The demo mode is fully functional for testing or exploring the software, but it is restricted to the demo date. License information will be briefly covered at the end of the video. The most frequently used functions are listed in the menu bar, while additional functions can be accessed through the dropping-down menu. EMCIP supports TIFF image in 8, 16, and 24-bit format. TIFF images are widely recognized for their high quality as they use lossless compression and can be stored a large amount of image data. Experimental HRTM image can be first select the area, adjust the size and orientation used to in EMIPA, an application for general HRTM image processing. Then the processed image reload to the EMCIP. The image can be shifted. Hold down the Alt key and click on the mouse right button. The information on scale bar can be updated through the color bar. Click to make the both ends match with the original bar here. Make sure that the labels are matched. Click a point in the image to define the center of the FFT area and drag the mouse for the size. The FFT area can be used in square or circle. FFT use the circular area is recommended here to avoid the cross shape striking on each of the FFT spots, which is usually shown in the FFT pattern use a square area. The appeal of FFT pattern can be enhanced using brightness, contrast, and the resolution ratios for further quantification. Two basic vectors should first selected by mouse pointer. And followed by refinement in the least square method. Click on the refine button several times until the area of the diffraction pattern becomes stable. If this refinement is unstable, it's usually due to the incorrect start point or improperly selected area of the diffraction spot. In that case, redo the corresponding selection and perform the refinement again. Now we make the CIP image. Click on this icon and we load the date we just get from the FFT pattern. Now we use the FFT date 2. We use the P1 symmetry here, which means use the original date. There are no symmetry applied to the diffraction date. All the plan group is here. Check your image to see which is matched the selected plan symmetry, then apply the symmetry to process the image. So we try P2 here and make a CIP processing. So we get an image like this. That means original date implied P2 symmetry. And we try the P1M1 symmetry here. We get a symmetry like this. Then we try the P11M symmetry. We get a pattern like this. It's similar but slightly different. And you have to make sure that your image have the symmetry. The CIP image can also display the pseudo-color mode if you select it here. And the best one we see here is the P1M1. We'll get a pattern like this. We can adjust the shell position without changing the symmetry because we want the origin point here, and in this case is allow the shift on edge, so you can apply that and apply it. So now you adjust the new shell without break the symmetry. It's like this, and you notice that this point not in the center of the unit cell but a little bit up. The parameter phase residue, the R value extinction ratio are evaluated based on the difference between the processed image and original image. In this case, there are no value extinction ratio. Generally, the smaller of this value is better, though they are not always the case. The CIP image can display also in contour map for further analyze. We can save the image here. There you have the image. The CIP image can also display as a contour map for further analyze. Display this image as a contour map. Click here to draw the image. Here we are. Is the one unit cell of the image. We got the intensity here, here, most in the intensity here and here. The parameter can be easily measured for the position. Use one unit cell here. Choose show coordinate here, and you click your mouse here. It will show that the horizontal is 0.57 of the unit cell length, and downsize is very close to the 0.5. Is 0.505, so it's considered this one in the vertical is in the half of it. You can also show two unit cell here by select or 3x3. Click here and draw. This is for 2x2 unit cell to show here. Exactly the same map here, but use a contour method. The display panel can resize to fit the monitor on your PC. From the menu bar, you can also view the serial number, which is linked to the license. You can also check the software version and access to the update through the Landyne website. Here is a website and contact info. The Landyne software suite and the user manual can be downloaded from the website. Annual license price of each application are also listed there. For new user, the first month's cost of the whole package is just $30.